Okay, continuing our review for the final. Question 12 has to do with the fundamental theorem of calculus, the second part. It's really a very easy question, but just to explain it, let me write down the first part of the fundamental theorem, the part that you're probably familiar with. This integral, the integral from a to b of f of x dx is equal to the antiderivative, uppercase f, of b minus uppercase f of a. Alright, that's part one of the fundamental theorem of calculus. Now, part two is really similar. It says, let's suppose you have this function, the integral from a now to x. So now the b varies, the second variable varies, of f of t dt. We're using another variable here. And we're saying, well, if we take this function that depends on x and take its derivative with respect to x, we get this f of x over here. Now, let's understand why this is really just a different form of number one. Alright, let's look at this integral. The integral from a to x of f of t dt, according to the first part of the fundamental theorem, according to part one, this is uppercase f, the antiderivative evaluated at x, minus the antiderivative evaluated at a. This part's a constant, this part depends on x. Now if we take the derivative of both sides with respect to x, on the right hand side we get, let me move this up a bit, on the right hand side we get the derivative of the antiderivative of little f. So this, the derivative of uppercase f, is small f, minus 0, since this is a constant. Alright, so the derivative of this is f of x, which is really what we said over here, right? This is equal to this. So this is the first part of the fundamental theorem. Okay. So really the second part is a different way of stating the first part. And now we're looking at, let's see, over here, we're looking at the derivative of this integral, and instead of having an x here, we have an x cubed. Okay. So instead of substituting in x for t, we're substituting in x cubed. So this is the cube root of x cubed. And remember, we're taking a derivative here, so we do the chain rule and we multiply by the derivative of this expression. Okay, so that's 3x squared. And that's it, we're done. Of course, the cubed root of x cubed is x, so we should, this is x. So we should express this as 3x cubed. Okay. And that's it, we're done. Okay, let's look at the last question in our review. Question 13, it's a related rate question. And it says the spherical balloon is filled with air at the rate of 10 cubic inches per second. Alright, so that says that the volume is increasing at the rate of 10 cubic inches per second. So dV dt is equal to 10. Find the rate at which the radius of the balloon increases. Find dr dt. when r is equal to 12. Okay, and we're given the volume of a spherical balloon is 4/3 pi r cubed. Okay, so what we do here is we differentiate both sides with respect to t. It's 3r squared times dr dt. And we know that dv dt is 10. This is 10. Alright, and so we want to find dr dt when r is 12. So let's write that when r is 12. We have 10 equal 4/3 pi 3. Alright, these actually cancel, these 3's. 12 squared dr dt. Let me just cross these 3's out. So now just solve for dr dt. And dr dt is 10 divided by 4 pi 12 squared. So let me write that as 4 times 12 squared, 144 times pi. And you could reduce that, and that would be, let's say the units would be inches per second. Inches per second. Okay, and that's the end of our review. Good luck with your studying, and see you at the final.